The C gate is 2 meters into the page. The density of the water is 1,000 kilograms per meter cubed. At what depth of water D does the gate open? You have to think about what it means for the gate to open. That means this gate is going to rotate that way and let water spill out over the top. First thing you're going to do is draw a free body diagram of A. You'll have two forces at A, one force at B, that's the stop down there that keeps the gate from turning in the other direction, and a nice distributed load due to the water pressure. The pressure at the bottom of that is going to be rho G times the depth, and we can consider what that would look like if we instead wrote the forces with the water pressure as an equivalent point load at some spot. I don't even want to figure out what it is right now. I know that I can do that. There is an equivalent force acting at that point. Now let's look at what those equations of motion would be. The sum of the forces in X, sum of the forces in Y, but what's the sum of the moments at, say, O point A? This gives me B times 500 millimeters and F times 500 minus D over 3. B tends to spin point A this way, F tends to spin it the other way. So these two forces have to be equal to each other. Realistically, as the gate starts to spin, what you must have is a net spinning that's going to go this way. That only happens when what you've really got is 500 minus D over 3 being equal to 0. So if B is greater than 0 and F is greater than 0, what you really need, 500 minus D over 3 to be less than 0. Essentially what you're saying is F has to be up here. I need D over 3 to be greater than 500. As soon as that's true, then F is going to tend to spin this gate to the left, and the gate will open and spill water. So now you can answer your question. D must be 1.50 meters to open the gate.